Welcome to my student today's lectures. We are going to learn electrochemistry. In the chapters now we have discussed the determination of ionic product of water. Last lectures also we have seen the degree of dissociation and dissociation constant we can calculate by using the conductance, specific conductance and here say constant. Similarly, now we have calculate the ionic product of water. Ionic product of water is defined as the product of concentration of hydrogen and hydroxyl ion. They are obtained from atom dissociation of water, and therefore water can be treated as the weak electrolyte by procedure they can use for determination of dissociation constant of weak electrolyte. They can apply as well procedure. Now we have see by procedure. Firstly, we are going to measure the conductance of pure water as well as conductance of 0.1 molar KCl solution also measured, and therefore by measuring this conductance of pure water and conductance of 0.1 molar KCl solution, we can determine the cell constant for this water. Now by calculations from the conductance of KCl solution, you can determine the cell constant as like the cell constant is equal to the specific conductance of KCl upon the conductance of KCl. Then next points we have calculate the specific conductance of pure water as like the specific conductance is equal to the conductance upon cell constant. Next, specific conductance and molar conductance for water can be calculated as by using the formula lambda C. C is the concentration, equivalent or molar. So name is a lambda C is equal to specific conductance we can calculate is here. So those conductance upon the concentrations as like 0.1, 0.2, 0.3 like these molar concentration solutions. Next points, the limiting molar conductance for water will be the limiting molar conductance of hydrogen and hydroxyl ion as like the lambda H plus plus lambda OH minus. Then the degree of dissociation of water is the ratio of molar conductance step 3 as like this step 3. The degree of dissociation of water is the ratio of molar conductance at this and the limiting molar conductance of water, and therefore degree of dissociation alpha is equal to this lambda C specific conductance of the water lambda C upon the limiting molar conductance for this water is the lambda H plus plus lambda OH minus like this lambda C upon lambda 0. Then from this degree of dissociation we can calculate ionic product of water as like the Kw is equal to alpha square into C by 1 minus alpha. For those calculations we can determine the ionic product of water. The next points, now we are going to discuss the transference number. Transference number mainly are to determine the fraction of current or the fraction of total current carried by the given type of ion in the solution. are named as transference number. When current is passed through a solution of an electrolyte, that time what happens? The ions of the electrolytes can migrate and therefore they can carry current through a solution. Therefore, hence movement of ions through a solution is the movement of charge and therefore the passage of current can take place. In solution, different ions move with different velocities and therefore they will involve different transfer of charges and hence different carrying capacity. Hence, the amount of current carried by an ion will depend on its velocity. It means that the different ions migrate with different velocity and therefore transference number can be defined to identify what type of the current carried by an ion which is passed through the solution due to movement of the given ion in the solution. So define of the transference number is defined as the fraction of total current carried by given type of ion in the solution is called as the transference number. As like Ti is equal to the Li, Ti is equal to I upon I. I is the capital I. So capital I is the total current and I is the current carried by ions. So various ions, they will carry the current. And therefore, the same can also express in terms of velocity of ions involved. It's the mu I. So mu I is the velocity. So this velocity of the ions, mu I is the Ti is equal to mu I upon the summation mu I. If the two different ions like cations and anions will migrate, then such electrolyte solution, the two types of ions as like the T plus and T minus having their velocities. So T plus is equal to the velocity mu plus upon mu plus plus mu minus. Similarly, other ions, anions like a T minus is equal to mu minus upon the mu plus plus mu minus. Hence, total current migrated, passage, total current passage is equal to the ions carried by total ions. So, total ions is cation and anions. So, T plus T minus is equal to the I. I is the total currents will migrate or carry the current by the ions. Next points now we have C is here. The transference number. Those transference number, they will different points which are very important to us, like this. It is the amount of current carried by ion will depend on its velocity and therefore the part of total current passed through the solution due to movement of ions. So define of transference number, it is defined as The fraction of total current carried by the given type of ion in the solution is called as the transference number. And this transference number is the Ti is equal to the Ii upon I. Ii is the current carried by I, the ion, and I is the total current. So these parts now we have seen in last slides. Next points now we have seen moving boundary method. In this method, we can determine the transport number either by measuring the velocity with while ion moves or by measuring the charge transfer by the movement of the ions. So these diagrams mainly are shows is here, like this is a moving boundary methods. This is a two electrodes. First one is a cadmium electrodes, and other it is act as the solution is anode. So HCl can fill up like this. Two boundaries will mention like a capital B and capital A. This yellow color liquid has to fill up as a cadmium chloride. Other liquid is a hydrogen chloride. So this is a circuit can join by the wires. After passing the currents through this wire in the solution, two different solution, then this liquid can move at two different levels. So this type of procedure or principle now we have see in this first principle. Principle mainly depend on the velocity of moving ion can be measured in terms of movement of the boundary. But such a moving of the boundary they will create between the two solutions of the electrolyte, and the movement of boundary they will observe by passing the current through the solutions. The two different electrolyte solutions are chosen in such a way that they will contain cation of the second electrolyte. The solution moves with the velocity lesser than the cation of the first electrolyte. The cation of the second electrolyte follows the cation of first electrolyte, and therefore it is also known as the flowing electrolyte. When current is applied, the second cation always lags behind, maintaining the boundary established between the two solutions. Therefore, the boundary moving, the volume shaped by boundary is determined from which the charge transfer can take place. Therefore, total charge passed through the solution by electrolysis can be measured in terms of current and the time for which the electrolysis is carried out. Now we have seen next point is a procedure. How will you carry out for those experiments? In this procedure can describe or determine the transport number of hydrogen ions in solution by hydrochloric acid. Right? So in this diagram it is a vertical tube, vertical glass tube is fitted with the cadmium chloride RES at the base of the wire. Cadmium electrode can shield at this point at the base, acting as this is a anode. A platinum cathode is fitted. This is a platinum cathode is fitted at the upper portion of the tube, and this tube forms the part of the circuit. This is a part of the circuit containing the DC supply, an ammeter and silver coulometer in these cells. When the current is switched on, Then tube is filled with solution of hydrochloric acid. A boundary gets created between the two solutions. The position of the boundary can be identified either by using indicator or by measurement the refractive index as two solutions. They will have different refractive indices. Current is about 30 milliampere can be passed through the solution. Then the half an hour, the distance moved by the boundary is measured. From the current values and time for which it is passed, the number of coulombs of current passed through the solution can be calculated. The amount of silver deposited in this coulometer can also be used for determination of quantity of electricity passed through it. Now we have seen the calculations. So how will determine how much amounts of the current can pass. Let's this small l be the distance moving by the boundary. Capital A is the area of cross section of the tube or cross section of the tube. Volume shaped by boundary, and therefore volume shaped by boundary will be capital V is equal to capital A into L. A is the area of cross section, L is the distance between the moving boundary, and therefore the equivalent of cation present in the solution is equivalent cations present in the solution n plus equal to Pc upon 1000. So this C is the equivalent which is present 1000 cm cube of the solutions. N plus is the number of equivalents of the positive ions present in the solution. C stands for the concentration of the electrolyte, right? And therefore charge transfer due to movement of these many equivalents of the cations will be Q plus, that is Q plus is equal to VCF upon 1000. Therefore transport number of the ion is given by like P plus, right? P plus is equal to Q plus upon Q. But you know that Q is equal to IT. Put this value in this Q. Therefore, this equation can rewrite as T plus is equal to VCF upon 1000 I. So this is a transport number of ion. It can be measured by using the formula T plus is equal to VCF upon 1000 into IT. V is the volume shape, C is the concentration, F is the Faraday, and I is the total current, T is the time passing the current. So we can measure the transport number of ion. T plus is equal to VCF upon 1000 into IT. The next parts we are going to discuss the factors affecting the transport number. So first factor we have the concentration. As the concentration of electrolyte increases, and therefore number of ions present will be increases, and hence increases the inter-ionic force of attraction between the cations and anions, and hence decrease the velocity of ions. Therefore, transport number of ions will decrease with increase the concentration. Hence, transport number decreases with increase the concentration of solution. Next factor, size of the ion. As the size of the ion increases, velocity of ion will decreases with a decrease in the transport number. However, in solution, ions do not get hydrated, and therefore size of the hydrated ion should be considered. Means, as the size of hydrated ion increases, the transport number of ions should be decreases. Next factor, nature of the coion. The transport number of the ions involves velocity of the coion. It means that the ion will move with the same velocity in all of its salt solution. The transport number in each case will be different due to different velocity of its coion. Next factor is the temperature. You know that by increasing the temperature, increase the velocity of the ions. Hence, transport number should increase with increase the temperature. But sometimes transport number of temperature will also increase the velocity of the coions, as well as we observe that increase in temperature, the transport number of all ions will be approximate limiting value of 0.5. Hence, temperature acts as a leveler, bringing velocities of all ions on par. And last factors, ion complexation. Complication generally increase the size of the ions and therefore decrease the velocity of the ions, and therefore decrease the transport number of ions. A unique case observed, cadmium iodide. As the concentration of iodide ions in the solution increases, transport number of cadmium ion decreases and even becomes negative. This can explain as complex form is negatively charged, and therefore cadmium ions are transported to anode instead of cathode. The complex form is cadmium tetraiodide 2- ions. Thank you.